On your screen, you see a table for the golfer closest to a career Grand Slam, and a career Grand Slam happens when the PGA golfer has won all four majors, which includes the Masters, PGA, US Open, and Open Championship. I think about this select group of active players as the Masters, our first major, approaches each year. From the table, the top left, we have Jordan, Rory, and Phil. They need one major each to complete the career Grand Slam. You can see their ages are listed, how many majors they've won, and the specifics as to which major each one has to win. Their world rankings, the last major they won, and so I give a probability. Jordan, I think, has a 40% chance of winning the PGA before his career ends. Rory has a 30% chance of winning the Masters. And Phil, being at the end of his career, it's probably going to be a struggle for him to win the US Open. Then there's four golfers, Brooks, Collin, John, and Dustin, and they have to win two majors. So their ages are listed, the majors they've won, and the two majors they have to win to complete the career Grand Slam. I listed their world rankings, the last time they won a major, and then the probability. Brooks, Collin, John, probably 20% chance of winning two majors before they're done. And Dustin, 5%, because he's near the end of his career, and it could be a struggle for him to win two majors. Basically, since the majors are starting soon, good luck to these 7 PGA golfers with this year's majors. Welcome back to another episode of Polymer Club's Ask Dr. Paul. Today we're going to highlight my favorite thermoplastic processing technique, injection stretch blow molding. So when your boss talks about ISBM, what do you need to know? Let's talk about the ISBM process using a simple 3-station rotary machine making PET bottles. In stage 1, we turn pellets into preforms. In stage 2, we turn preforms into bottles. And in stage 3, we eject those bottles. Bottles typically house liquids in which the container is wider than the mouth opening. On your screen is a schematic of the 3-station ISBM process. Basically, we're converting pellets into preforms, and that's really done in an injection molding step. So if we're talking about PET, we have to melt it. We got to get above 250 C. We go from hopper to barrel to gate into the cavitation. You can see we're actually molding 4 preforms at the same time. But basically, there's a cavity on this side of the preform, and then up at the top, that's the core. That metal core comes down, and you can see where the preforms are held. That's the lip cavity. So you got metal all around, and you make this great part. So everything comes down, you make parts. Then how do we demold? We take the core up, we take the lip cavity with the part up, and we go over to the next station. But the highlights of preform is you'll have that gate remnant at the bottom here. You'll also have smooth inside the neck. That's because there's metal in there. There's a core on this side, and you've got these detailed threads because metal was on all sides, and then we transferred to station 2. In station 2, we have a second set of tooling, the stretch blow molding tooling, and basically we have the preform with the lip cavity, held by the lip cavity, and it's brought over and it's brought into the stretch blow molding tooling. And you can see that on the right-hand side. Basically, all we're trying to do is have the preform at the right temperature and pressure to blow out. I call that a taffy field to make this preform into this. Obviously, if it's too cold, the temperature, you just can't, it's just too glassy and you won't be able to make this bottle. And if it's too compliant, if it's too gummy, then this preform will essentially just pop and you won't be able to make a bottle. But basically, once you got the preform in the tooling, remember we're talking stretch blow molding. So there's stretch rods to stretch down and then air blows out. So if you think of the polymer chains, they get oriented down, then they get oriented out. Biaxial orientation makes a great bottle. We still have this bottle by the lip cavity, so there is nothing's going on with the threads. We're just blowing down here. When we're done, the tool opens, the lip cavity holds it, and it goes off to the 3rd station. But what are the details that we know when we've made an ISBM bottle? The first thing is this knob at the bottom. So the preform, the gate remnant here becomes the knob down here. So the stretch rod pushes it down to the bottom of the tool, and that extra material always gives you that knob. So we've got the knob, we've got the smooth inside here, we've got these great detailed threads, and this lip cavity transfers to station 3. In station 3, we have bottles that are held by the lip cavity, transferred to station 3. The lip cavity opens, drops, and essentially ejects the bottles. So if you think about each station, they have to be constant time because they're on a rotary system. If it's 7 seconds to make a preform, then it's 7 seconds to make a bottle, and it's 7 seconds in the ejection station. With ISBM, we have 2 sets of tools. We have the injection molding tool, the stretch blow molding tools. And so the tooling costs are high. The cycles are great. They're fast. But what do we get from ISBM bottles? Detailed threads. We won't leak. Sticky soda being turned on its side. We have uniform wall. We have that telltale bottom knob. And we have smooth inside the bottleneck. Basically, we use ISBM to create bottles that can be capped and can pass drop testing. Maybe 1 meter is your common test, and it contains liquids without leaking. So that's the goal of ISBM. Knowing the injection stretch blow molding process and the detailed threaded bottles it produces, that's working knowledge. Remember to like, subscribe, turn on notification, and even share if you appreciate the content. You can visit our website to learn more about our upcoming Polymer Applications course. I'm Paul Nash for Polymer eClub's Ask Dr. Paul. Thanks for watching.